today's video, we'll discuss sleep and dreaming. Sleep is a natural state of rest for the body and mind that involves the reversible loss of consciousness. Our sleep schedule is mediated by what is called a biological rhythm. This is a periodic physiological fluctuation in the body. Biological rhythms are controlled by the body's biological clock, which includes annual or seasonal cycles, 28-day cycles, and 24-hour cycles. Our circadian rhythm is a daily behavioral or physiological cycle. Circadian rhythms include the sleep-wake cycle, body temperature, blood pressure, and blood sugar levels. The suprachiasmatic nucleus is a small structure in the brain that uses input from the retina to synchronize its own rhythm with the daily cycles of light and dusk. Biological clocks can be desynchronized or put off their cycle by such things as jet travel, resulting in a condition sometimes referred to as jet lag, but also by changing work shifts or insomnia. With regard to jet lag and resetting one's biological clock, it appears to be a good idea to spend as much time as possible in daylight. Melatonin can also help reset the biological clock. There are many theories for why people need sleep. From an evolutionary perspective, sleep may have developed because animals needed to protect themselves at night. A second explanation is that sleep is a way to conserve energy. Sleep could also be a restorative function. Finally, some researchers think that the need for sleep centers on the role of sleep in brain plasticity. Sleep enhances synaptic connections that help with new learning and memory storage. Sleep also plays a role in how experience influences the brain. Sleep deprivation affects attention, problem solving, and even moral judgment. Research has shown that extreme deprivation of sleep can cause hallucinations as well as speech and movement problems. There are different stages of sleep and wakefulness, and these stages correspond to massive electrophysiological changes that occur throughout the brain as the fast, irregular, and low amplitude electrical activity of wakefulness. Using an EEG to monitor the brain's electrical activity, scientists have identified 2 stages of wakefulness and 5 stages of sleep. When people are awake, their EEG patterns exhibit 2 types of waves, beta waves and alpha waves. Beta waves reflect the state of wakefulness. They are the highest in frequency, lowest in amplitude, and are more desynchronous than other waves, meaning they do not form a very consistent pattern. Alpha waves reflect the state of relaxation, but still when one is awake. They slow down, increase in amplitude, and are more synchronous or regular. The first stage of sleep, stage N1, is characterized by theta waves, which are slower in frequency and greater in amplitude than alpha waves. This stage is characterized by myoclonic jerks or sudden muscle movements. The next stage of sleep, stage N2, still has theta waves, but also has sleep spindles, which involve a sudden increase in wave activity. Stage N3 sleep is characterized by delta waves, the slowest and highest amplitude brain waves during sleep. This is the time that our brains are the least likely to be woken up. As a person goes through sleep stages N1 through N3, they drift back up towards wakefulness but do not reach stage N1. Instead, they enter REM sleep. REM stands for rapid eye movement. This stage is an active stage of sleep in which dreaming occurs. The EEG patterns for REM sleep show fast waves similar to those of relaxed wakefulness, and the sleeper's eyeballs move up and down and from left to right rapidly. Some researchers believe that REM sleep plays an important role in memory. One sleep cycle, or the time spent going through the stages of all the sleep one time, last about 90 to 100 minutes. The sleep cycle recurs several times throughout a night. The night's first time in REM sleep lasts only about 10 minutes, but the final time in REM sleep may last up to an hour. In the next video, we will focus on sleeping disorders and theories related to dreaming.